We're recording now, guys, so save further comments later. Okay, and we got some questions to solve. These are solved questions, yeah? Solved questions usually involve either a linear or a quadratic equation. You got that? Now, you look at this second one, and you're going, like, first of all, there's some major differences here. That's a 2x angle, and that's an x angle. They're like completely different. They're like apples and oranges. So what we're going to do is we're going to look up something in the tables to see if we can help ourselves out here. You go to the tables and you look for cos 2a. You'll need your tables on page 14. And what happens when you look at your tables on page 14? You'll see cos 2a equals cos squared a minus sine squared a. What you've done there is you've solved your first problem. The first problem was the presence of two different angles. Is that alright? Now you're down to cos squared x minus sine squared x equals 1 minus 2 sine x. Does everybody see that with that first move all my angles are now compatible? What's not compatible? The functions. There's two functions. What two functions do I have? Cos and sine, and I have another sine. To make a decision here, it's very easy. You look for cos squared and sine squared. Alright? Now, what's making me choose changing cos over changing sine? Well, one of the sines isn't squared, which makes it a lot harder to change. So it's really easy to change cos squared and sine squared, but it's not easy to change cos and sine. So by that reason I should change cos squared x. Now what can I change cos squared x into? You're nearly there. Who said that? Well done.
Where is it?
That is on page 13, I think. Top left, top right, or...
Oh my god.
Yeah, you see it? Okay, now, using this knowledge, I'm going to replace the cos squared x with 1 minus sine squared x minus a sine squared x equals 1 minus 2 sine x. Now, what could I do with the sine x's, can you tell me? Pick a letter, any letter that we haven't already used. A will do. 1 minus, anybody? A squared minus a squared equals 1 minus 2a. Happy enough with that? Move it all over one side. 2a squared minus 2a. Do the ones cancel? Yeah? This could be a reference number, but it just happens that it's not. Does that make sense? Now how do I factorise that? So 2a into a minus 1 equals 0, then what? 2a equals 0, or a minus 1 equals 0, are two answers? And equals 0. Now, what did I say a was again? Sine x equals 1, or sine x equals 0. Do my answers need to be in radians or degrees? Radians, okay. Will you guys do me a favour? Will you go to page 13? The boxes, see the boxes? When does sine x equal 1?
90.
And what's directly underneath the 90? I think pi over 2 is underneath the 90.
Oh, right, sorry, oh, give me pi.
No, I mean down.
For the radian,
Yeah, so the radian measurement would be when sine x equals 1, x will equal pi over 2. What about when x equals 0? What do you have there?
0.
And there's one other answer. Pi. And there's another answer. 360 degrees is the same as 0. So, who said that? Is that you? Oh. 2 pi. And there's all our answers right there. Is that okay with you guys?
Yeah.
Okay, great. Now, you're looking at this and you're going, okay, first of all, Is there an angle problem here?
No.
There is no angle problem. Would everybody agree with that? Okay, there's no angle problem. So there's a function problem, right? What do you think you can do? Make a choice. You have to change one of them. Which one do you want to change?
Tan.
We'll change tan. What can we change tan into?
Sine over cos.
Okay, we'll change tan into sine over cos. Okay? But this might work. So what effectively we're going to get here is 2 sine theta equals root 3 sine theta over cos theta. Now, bring the cos theta up to the sine theta. Everybody right with that? And that becomes 2 sine theta. And what can I do with the sine theta on both sides? Or if you really want to bring that underneath, and then they cancel, yeah? So what am I left with? 2 cos theta equals, anybody? And then cos theta? Cos theta equals what? 33 over 2. What two quadrants is cos positive in?
On 2 rows.
Okay. Get the reference angle. Cos inverse root 3 over 2. I'll do it for you. It's 30 degrees. So what are my two answers then? 330 and 30. We good? Okay. Let's hope so. Keep going. Oh, these two. They aren't as bad as you think, actually. Okay. How many types of angle do we have? How many types of angle do we have? 1. How many functions do we have?
1.
Oh, that's brilliant, isn't it? So how do we finish it off? Change tan into pick a letter, any letter. A squared minus 3 equals 0. Then what? A squared equals 3. A equals and okay. So what you've effectively told me is that tan theta equals root 3 and minus root 3. That's what effectively you've told me, right? So let's start off with the positive one. What's the two answers for the positive one? A and T. What's the reference angle? Tan inverse root 3? 60 degrees. So what's my first two answers? 60 degrees here and in T? 240. Okay. Now I need to get two negative answers, which is located here and here. So what's the answer for the second one? 120. And the answer for C?
300.
It's fish in a barrel, isn't it? And then, if you're wondering about the other one here, see cos squared theta equals 3. All you need to do there is this. For this one here, guys, all you have to do is cos squared theta equals 3 over 4. Change cos into a letter of your choosing. X squared equals 3 over 4. Square root 3 over 4. What do you get? Square root 3 over 4.
3 over 2.
Root 3 over 2. So what you're telling me is that x equals root 3 over 2 or minus root 3 over 2. And you just find out cos theta equals root 3 over 2 or minus root 3 over 2. It's easy enough. Okay? This one. This. That. Whatever. Now, what are we doing here, guys? What does the solution mean? So imagine I gave you this. Imagine this equation here. Give me a second. If I said x equals 3 is a solution of this, how would you prove it's a solution? I'm saying an answer to this question is x equals 3. Sub it in. 3 squared minus 2 times 3 minus 3. 9 minus 6 minus 3. 0, 0 equals 0. Yeah, cool, I'll get that done now. Yeah, do about 20 past 5. Yeah, yeah. Okay, go. Alright. Now, what we're doing next is we're doing the same trick, aren't we? We sub it into this, and what should happen? We should have to get 0, don't we? Okay, so if theta is pi over 6, what's 2 theta?
2 pi 12.
No, you only multiply, when you multiply a fraction, you only multiply the numerator by the number, not the denominator. So, 2 pi over 6, which is pi over 3. Insert it in, so it's going to be k cos, anybody?
Pi over 3.
Pi over 3, yeah, minus,
9 squared pi over 6.
yeah, minus 1 equals 0. Now, using your tables, what is cos pi over 3? It's 60 degrees, is what? A half, isn't it? So that's k times a half, which is k over 2. What about, what's sine pi over 6?
3 degrees, so a half, I guess.
And then what's a half squared? Because it's squaring that. Huh?
4.
Okay. Now, common denominator maybe? What would common denominator be?
4.
So make that 2k over, and then this to be 4 over 4. They don't matter, do they? Then what?
2k minus 3.
2k minus 5 equals 0, and k equals? K equals 5 over 2. Okay, so look, that's a difficult question if you haven't seen it before. Okay. Now, what's it saying next then? Hence, solve that, isn't it? Now, we're talking about solving something like this. There's a small problem with solving something like this. Have I ever asked you guys to solve? Actually, wait a second. Yeah, we're all right for a second. Somebody tell me what is the 2 problems with this equation. What's the first problem? Check the angles, check the functions. If you got that, repeat that one more time. Check the angles, then check the functions. Check the angles first. How many different angles do we have? We have a 2 theta and a. Which one would you usually change? You usually change the bigger one, don't you? What can I change cos 2 theta into? 2.5 times cos squared theta minus. Okay, let's continue to work on this. I can either change cos squared theta or sine squared theta. Would you agree that there's 2 sine squared thetas in comparison to 1 cos squared theta? You can do it either way, but I'd be lazier, right? So what's the lazier way of doing it?
Any cos squared theta.
So you highlight the cos squared theta, and what are you going to change that into?
1 minus sine squared theta.
You're going to change that into 1 minus sine squared theta. So it's going to be 2.5 into 1 minus sine squared theta minus sine squared theta minus another sine squared theta. What's that? Minus 1 equals 0. Now what?
Multiply by
Would you agree that's 2 of them?
it.
2 sine squared thetas, yeah? Multiplying by?
0.5.
Now, what do we do? What have we done the last couple of times we got here?
Sub in x or something.
Yeah, x, yeah. So 2.5 minus 5x squared,
Minus x squared.
yeah, minus 1 equals 0. You happy enough with that? How many x squares am I looking at here?
4x squared.
I think I'm looking at 6x squared, am I?
Oh shit.
And then the other side?
Minus
Plus 1.5. 6x squared equals 1.5. What's 1.5 divided by 6? You guys tell me.
4.
Huh?
Yeah, 5, 3.
It's a quarter, right? Now, square root it. Square root a quarter. What you get? Okay. And don't forget that. And what did we say x is again?
Sine squared theta.
Sine theta, not sine squared theta. Now, what two numbers do you want here?
Top 2 and the bottom 2.
Reference number is 30 degrees. If I'm doing the positive answer, which is when it's positive, I'd be in here and here. And what two answers are they?
30 and 150.
Yeah. And when I'm doing the negative answer, which is this one here, where will I be?
210 and 330.
210 and 330. Good job. Yeah, very right with that. Now there's only one final type of question here. They're going to get us to do some fancy products. I'm going to need all you guys. Oh, I don't need it. So I'm going to go everybody onto page 14 and 15 of your tables. What does this want me to do? It wants me to add a sine and a sine. So what's the rule for that? What's sine A plus sine B?
2 sine A plus B over 2.
2 sine A.
Plus B over. No, it's like fraction A plus B over 2.
Oh yeah. Yeah. And the other one? Oh, dear.
Cos fraction A minus B over 2.
Sine or cos?
Cos.
A minus B over 2. You happy with that? What's A? What's A?
5x.
What's B?
X.
Add them together.
6x.
Divided by 2.
3x.
So you get 6x. A plus B would be 6x. 6x divided by 2 is 3x. A minus B. 5x minus x.
4x.
4x divided by 2.
2x.
Okay, that's easy money, isn't it? And what about the bottom? A cos plus another cos. What's cos A plus cos B? 2 cos A plus B over 2. And what's A and B? Same thing, isn't it? 5x and x. So we're going to get 2. That's going to be 6x over 2, which is? And 5x minus x, 4x divided by 2. What cancels? What's left? Sine 3x over cos 3x, which is? Tan 3x, good job. Okay, proven, yeah? Everybody cool with that? Now, how's the word hence? What does hence mean when you see it? Okay, then what? So if we can replace this with tan 3x equals 1. How many revolutions do I need to go through? 3, which means how high do I have to go up to? 1,080, would you agree with that? 1083 evolutions worked. When does tan equal 1? What quadrants? When does it equal 1? What quadrants does it equal 1 in?
In the bottom left and the top right.
Okay. What's tan inverse 1? Get the reference angle. So what's our two answers?
1.5 and 2.25.
Do another rotation.
405 and
Add on 360. Do another rotation. 7, 6,
5,
and
9 and 4 or 5.
yeah. Good with all that. Now 3x equals all those numbers, yeah? Do you like it done that way in the sections, and I just keep putting out the numbers in each section as it rotates? I don't know, it's the first time I've ever done that. I was feeling inspired with it.
Yeah, so.
Okay, divide by 3. What you get? 15, 75, 135, 195, 255, 315. Merry Christmas. Now,